Okay, as we said before, we will continue to add to the net zero story because this is now an important and relevant topic for this course under geoengineering as well as under other climate studies. So I will link these podcasts elsewhere as well. So McKinsey and Company wrote this report, The Net Zero Transition, just now in the beginning of 2022, and it's focused on what it would cost and what it would bring. Obviously, it's a big report, over 200 pages. I'm going to just give it a very brief executive summary here, and if you want further details, obviously you can go and read the report. The annual global emissions in billion metric tons per year, to remind ourselves, has gone up continuously over the last many decades, and there have been little dips because of financial crises and of course COVID, but now we are already recovering from the COVID emission dip, even though COVID is not completely gone yet. In the meantime, the past 50 years, methane and nitrous oxide emissions have also been steadily increasing, remembering that they tend to be an order of magnitude smaller than CO2, but obviously we always have to look at their concentration in the atmosphere, their global warming potential, and their residence time. So annual global methane emissions have gone from about 250 or so million metric tons per year in 1970 to now over almost 400 million metric tons by 2018, and the annual global nitrous oxide emissions have gone from under 6 million metric tons per year to close to over 9 million metric tons per year. So the meantime, the energy prices, the impact of COVID on economies and various geopolitics have been playing their games as usual on affecting climate action and the fight against global warming. And this is a New York Times article on February 2, 2022. How spiking energy prices complicate the fight against global warming. Oil and gas prices are soaring while coal is reaching record highs worldwide. So this is absolutely the worst news for global warming action in terms of having to leave coal buried in the ground, but in fact its use is quite high and acceptably high. Here is what the upheaval could mean, and that's the article goes into that. And the article came in Science magazine, which shows the satellite map of the highest emitters of methane. So major gas pipelines, for example, here, emissions in 10 tons per hour or 500 tons per hour in different circle sizes here. And you can see that the largest emitters are spread across North and South America, even Africa, parts of Europe, into Russia, and down into China and India as well, and Australia. Why leave them out, right? So this obviously relates to the commitment made under the Glasgow Agreement recently in November 2021 to eliminate or maybe reduce methane emissions by 2030 and so on. So we continue to chug along doing things as usual, business as usual. But here are 6 characteristics of the net zero transition according to the McKinsey report. One is that it has to be universal. So all carbon dioxide and methane emissions today come from 7 energy and land use systems. These are the carbon dioxide in white, methane in gray, and the size of the circles share corresponds to the share of total of each greenhouse gas emitted. So there is the power. So power emits mostly carbon dioxide, 100%, and industries emitting carbon dioxide as well as methane, depending on what industry it is. Mobility, so transportation is emitting a lot of CO2. Buildings emit a lot of CO2. Agriculture has a little bit of CO2, but mostly all methane. Forestry, depending on the details, can be mostly CO2, but also methane, and of course landfills and waste emit a lot of methane. So keeping that in mind, the second characteristic is the significance of net zero transition. Capital spending on physical assets for energy and land use systems will need to rise by 3.5 trillion per year for the next 30 years to an annual total of 9.2 trillion per year. So here are the existing spendings. So 2.7 trillion of continued continued spending on high emission assets, 2 trillion in $2 trillion in continued spending on low emissions assets, $1 trillion spending reallocated from high to low emissions asset, and new spending of 3.5 trillion would be needed on low emissions assets versus today. So that's for the next 30 years. The third characteristic is that the cost would be front-loaded, so global capital in the transition could rise in the short term before falling back. So here is the 2020 spending level at 6.8% of the global GDP. Across 2021 to 2050, it would rise to over maximum of 8.8% during 2026 to 2030, and then falling off and coming down below the 2020 levels by 2050. So cumulative spending of around $275 trillion, or about average of about 7.6 trillion of the global 7.6% of the global GDP across 2021 to 2050. So obviously, considering the other issues we discussed elsewhere about discounting the future, one has to remember that this spending is all for the future of net zero, and the beneficiaries are the future generations and the posterity. So one has to decide based on other values whether this is worth spending or not. Obviously, it's not that easy because the complicated negotiations still go on, while the emissions still continue to rise on business as usual scenarios. 4, it's going to be all uneven. Developing countries and fossil fuel rich regions are more exposed to the net zero transition compared to other geographies. So looking at the size of the population of the countries, and on this scale looking at the countries with higher transition exposure, trending towards lower GDP capita. So in this case, you have lower transition exposure and lower populations, US being a good example, and there are many other countries. China is up here, Brazil is here, and India is in this corner with among the highest transition exposure and lowest GDP per capita. Okay, so this has to be kept in mind. Some industry sectors are also more exposed. So 20% of the GDP generated by sectors with the highest degree of exposure. So that's what will have to be dealt with in terms of bringing everybody along for the transition to net zero, because the planet as a whole has to do it, and each member of the IPCC and the global countries have to do it. So fifth, exposed risks, $2 trillion in value in power assets alone that could be stranded by 2050. Things like coal that we cannot dig out and burn, fossil fuel that may have to be left in the ground, and so on. So as high emission assets are ramped down and low emissions ones are ramped up in the transition, risks include rising energy prices, energy supply volatility, and asset impairment. The New York Times article I just pointed to is exactly this that is already playing out. 6, rich in opportunity. So the transition would actually provide opportunities. The shift to a net zero emissions world will create opportunities for businesses and countries. These could be in 3 areas: decarbonizing processes and products, replacing high emissions products and processes with low emission ones, new offerings to aid decarbonization, including supply chain inputs, infrastructure and support services. So these estimates are based on Net Zero 2050 scenario from the so-called NGFS, or Network for Greening the Financial System, which has an even chance of limiting warming to 1.5 degrees C. This is a hypothetical scenario. It's not a prediction or a projection from the IPCC models or anything. It's just a calculation based on how to get there to below to 1.5 degree C. There are lots of details that are included in the report that I'm not including in this podcast. So let me stop with these 6 characteristics and then come back and add a few more points about the transition to net zero, what it would cost and what it would bring. Okay.